Everybody, how you doing? I know I'm already coming off camera, but it's it's Mr. D, and I'm glad everybody did very well with the Hurricane Irma here in Florida. I do have to make this lesson a little brief, more than usual, and I apologize for coming on so late. But lesson 11 is kind of going over one more day. Today we went over concept 4. Tomorrow we're going to actually do a little bit of practice and jump into lesson number 12. Now, what we're doing here is we're now taking ratio tables, actual ratio data. And what we are doing is that we are now going to compare the two to figure out rates. So in other words, like the example I gave a student today, a lot of the students love playing football. And I said, well, what if you had to, let's say, you want to pick the fastest players. So you start doing some tryouts. You do the 40-yard dash. Let's say Jimmy can do the 40-yard dash in 10 seconds. And Mariah can do the 40-yard dash in 20 seconds. But then it rains. And all of a sudden your 40-yard dash field is now 20 yards. Well, can you still use people? Can you still use 20 yards? Yes, you can, and we're going to explain how and why. And today what happened is that I noticed one of the students was like, well, wait a minute, 20 yards is half of 40. So we can time what a kid runs in 20 yards and double it. And I'm like, there you go. Now you're getting the idea. So let's take a look at what I did up here, all right? Now this is straight from, let me see, I got a new flashlight here, my $40 Hurricane flashlight. Let's see if this adds a little bit of light there. There we go. All right. If you don't see me, I apologize. So I'm just still working out the kinks on my home setting here. All right. So here we go. And I do, once again, I apologize for the handwriting. You know, the surgery, I'm still doing physical therapy. I'm doing the best I can. But I want to get this video in and get the idea in before the battery on my notebook dies. Okay. So here we go. We're doing Module 1, Lesson 11, and it says here, students will solve problems by comparing two or more ratio using tables. I should say ratio tables using data, but that's okay. So the question is posed, use the tables to see who is the fastest swimmer. Now, before the hurricane, I did an example of who ate the fastest hot wings, me or my roommate Josh. And we had 2 different times. And you know, a person stopped watching it, and they would record our quantities at the times, and it wasn't the exact same rate. So you had 2 different tables with 2 different quantities of how many wings were eaten and how much time. So the kids were kind of confused, but I'm like, you know what, let's switch it to this. Here, Sarah is a swimmer, and we have where it says, let me do that, there we go. Here it says time. And you have, okay, the time is done in minutes, 3 minutes, 5 minutes, 12 minutes, and 17 minutes. And this is distance, and we're going to say it's in meters. Let's go metric, okay? So in 3 minutes, she swam 75 meters. In 5 minutes, she swam 125. In 12 minutes, she swam 300. And in 17 minutes, she swam 425 meters. Now, it's not really the world's best rate. I mean, this is what happens. Like when I do my 5Ks and I look at the kilometers, sometimes I'm not running the same rate all the time. So we got to figure out who's running the fastest. So here we go. Ava here in 2 minutes swam 52 meters. In 7 minutes swam, this is supposed to be 182 meters. In 10 minutes, she swam 260, and then in 20, she swam 520 meters. Now, how do you figure this out? There's multiple ways to do this. All right, the first way is to always see if you can get to the unit ratio. Now, a unit ratio is always something to 1, okay, something to 1. So it would look like this. Let me change the colors up here. I haven't used green yet. Okay, so, you know, one method So I'm going to put method 1. I'm going to call that, oops, don't want to do the sign there. We're going to call that the unit ratio. And moms and dads, guardians, aunts, uncles, everybody, if you're worried about my handwriting, I'm trust me, at school I don't write like this. It's a small board and these markers, whatever. So unit ratio, which means that you need to have A to B, where B equals 1. Okay? So how do you do that? Well, you're going to either scale up or scale down. We're going to scale down. Okay, scaling down. We went over that today, scaling down. And there's 2 ways to scale down, division or subtraction. And we found that division was the easiest. So you start with your lowest numbers here. And you got 3 to 75. So you got 3 to 75, which when you shows that the value of the ratio is really a fraction. So that equals 3 over 75 equals. Then you got to ask, is there something that can go into 3 and is there something that can go into 75? A lot of students have a little difficulty with the 75. Hold on one second, please. A little technical difficulty there. Sorry. A lot of students have difficulty with some of these big numbers. I said, well, think of it as 75 cents. And you got a 3. So the highest you can go to do division is the 3. You can't go beyond it. So let's do 3. So you're going to divide by a constant. 3, 3. Now 3 into 3 is 1. So we have our 1. So this might actually be A equals 1 for this one. So I should actually make it A or B equals 1. Okay? So 3 divided by 3 equals 1. 75 divided by 3 is 25. And then we turn it back from a ratio value of a ratio into its unit ratio, 1 to 25. So if I could, I would put a little dash right here, which now tells me that in 1 minute, she swam 25 meters. Now, can we do that down here? Let's take a look. So here you have a ratio of 2 to 52. Now, my students are incredibly intelligent, and they all know from their great 4th grade and 5th grade teaching that when you get 2 even numbers, 2 always goes into it. So we're going to turn that into its value of a ratio, 2 over 52. We're going to simplify it by the greatest common factor, and it looks like it's going to be 2 here. So you're going to divide by 2. You're going to divide by 2. 2 divided by 2 is 1. 52 divided by 2. And just to give you an idea of how I discuss division the new way, here it is. You got 5 tens. You got 2 friends. How much evenly will each friend get in regards to, hold on, let me see if this light, there we go, much better. Oh no, see, we're still working out the kinks. There we go, still working out the kinks. And, that works. All right, so I tell the kids, you got 5 tens, you got 2 friends. Well, how many $10 bills do you each get evenly? You're going to get 2 with 1 remaining. All right. So here you go. You're going to have 2. You got that 1 remaining. Okay. Now that you got 1 10 and 2 1s. Okay. So basically, how many times is 1 10 and 2 1s? That's 12. How many times? It goes in 6. Or if you really need to see it, I always tell everybody you write division problems like you say it. Top to bottom. 52 divided by 2. 52 divided by 2. 2 goes into 5 twice. 2 times 5 is 4. So that really means 2 goes into 5 tens 2 times. Subtract. You now have 1 10 left and 2 1s. 2 goes into 12, or 1 10 and 2 1s 6 times. Now you go over here. All right, maybe I do need this back on. I'm sorry. We're still working out the kinks. I apologize, everybody. All right. So I go over here, and you see that now for every 1 minute, we got 26 meters. So who's the fastest swimmer? According to this, it's Ava. In 1 minute, she can go 26 meters. In 1 minute, she can go 25 meters. She's going further, faster. So that's Ava. But the one thing, the beauty about Eureka Math, is that there's not just one way to solve these concepts. Because we did a problem today where this method 1 unit ratio didn't work. It did not go through. And there was a student today who actually, he figured it out like that. And I was, whoa, good job, good job. I don't want to say his name out loud. But I was like, you did great. You figured it out. This is what he did. So watch. So let me erase all of this, and we're going to go to a different method. Okay? We're going to go to a different method here. Okay? So I'm going to erase the data we just found. Let's say that we don't have this. This is method 2. And I say it's this. Compare common values. Okay? Compare common values. So basically what this means is you need to find in each table something that is the same, something that is similar. And you can't go, oh, well, let's go minutes here, meters there. No. If you're going to compare time, it has to be time here and time there. If you're going to compare meters here, you got to compare meters down here. Distance, distance, time, time. You have to compare the similar items, and you got to find a common value. I hope that made sense. It's going to. Trust me. Watch. Here we go. So I look at the time here, and I got 3. I got 5, I got 12, I got 17. I look at the time, I got 2, I got 7, I got 10, I got 20. None of these are the same. Let's go down to the distance. 75, 52, 125, 182, 300, 260, 425, 520. Nothing is the same. There's, how do we do this? How can we solve this conundrum? It can't be done. Because I say if you can't find the common value, create the common value. All right? Because that's what we did today. If we have 3 kids run for 40 meters, 40 yards, and it rains on that third kid's trial, and he can only do 20, or she. So 2 kids got 40. We could compare the 40 and 40 there. 1 kid did 20. We could turn that 20 into a 40 by multiplying by 2. And if we multiply the distance by 2, we therefore can multiply the time by 2. And it goes the other way around. The kids that did the 40, why don't we scale down, use the words, scale down and divide by 2. So it goes either way. So watch. So I'm looking here, and I'm trying to see if there's something in common. And I see that the 5 here and the 10 here, there could be a commonality, okay? A 5 and a 10. Because here we go, because that's 2 groups of 5. So watch this. I'm going to compare the 10 minutes to the 260 meters of Ava, and I'm going to compare it to the 5 minutes of the 125 meters that Sarah did. Now, some kids automatically going to say, she went faster. She went faster. Look what she did in 5 minutes. But it's not an accurate representation. You must make it equal. You got to make it fair. So the time has to be the same, or the distance has to be the same. So I tell the kids, if you're going to scale up, make it larger, you got 2 ways, multiplication or addition. Now in this case, we're going to multiply, and I'm going to use what's called the bridge method again. So that equals, I'm going to create an equivalent ratio. So 5, and this has to be 10, because I just know that You know, these are some of those need to know facts. How does a 5 become a 10? Well, they're connected. So 5 to 10, 5 to 125 equals 10 to a number. So how does a 5 become a 10? Multiplying it 2 times. And so you're doing, remember the earlier videos, you have to use the same constant. 2 times. So 125 times 2 equals, and some kids actually had a hard time doing this today. And I said, you know what? Don't think of it as 125. Make it $1.25. All of a sudden, it's like light bulbs go off. $1.25, I can do that. $1 and $1 is 2 and 25 cents. 25 cents is 50 cents. So it's $2.50. But remove the decimal, it's 250. Now you have a common, okay? You have a common value, 10 and 10. In 10 minutes, she went 260 meters. In 10 minutes, she went 250 meters. Who went farther faster? Or who went farther in the same amount of time? It was Ava. So now we have proved it 2 ways. We scaled down to the unit ratio, and now we scaled up to find a common value. The best part is you don't even need to do this one way. I want to check my work. I want to see if this is true. That's a good question a student would ask. So watch. Watch what I do here. Same method, different numbers. So I sit here and I'm like, well, there's a 12 and a 2. They're connected. So if I can prove, yeah, let's do that. So let's compare 12 to 300. And let's see that to the 2 to 52. Now, I already know the 12 to the 300. I already know the 12 is the highest I got to go. So I got to turn the 2 into a 12 so I can make the time the same. Let's do that. Watch. So I'm going to do bridge method to create an equivalent ratio. Okay? How does a 2 become a 12? Well, you got to know your multiplication tables. If you don't, it's okay to skip count on hands. 2, 4, 6, 8, 10, 12. 6 times. Times 6. 2 times 6 is 12. So now we have this. And they're going to so we know that in 12 minutes, Sarah did 300 meters. Now we got to do this one. Multiply this by 6. Mister, that's too difficult. Okay, I'm going to do standard algorithm way, old school method. 52 times 6. 6 times 2 is 12. Carry the 1, or carry the 110, because 6 ones is basically 12 ones. I mean, 6 groups of 2. 6 times 5 is 30. You add 1 more. It's 312. So, in 12 minutes, Ava did 312 meters. In 12 minutes, Sarah did 300 meters. There it is. Now we've done method 2. We've found common values and compared them. And the students are like, well, where else would I do this in the real world? Well, if you're doing baking or cooking and you want to, see who's, okay, when I do my lemonade, I put in 4 cups of water, 4 parts water, some people say that, 4 parts water, and I'll put in 2 parts lemonade mix. Or I'll put in 8 parts lemonade, 8 parts water and 3 parts lemonade mix. And then you get to compare, well, why, what's going on? Why does yours taste better? Why does yours taste more watery? And then you break it down to the smallest unit ratio like we did before. Or you can then figure out, well, wait a minute, if I want to make more of something, I got to increase it. I got to scale it up. All right? Students were asking me before, is it possible to do it with the distance. And the thing is that you probably could. And it's like, okay, I'm looking at it, and I'm like, I mean, you'd have to almost arbitrarily pick a distance out there, because 300 and 300 is 600, and I mean, it's not really going to work here. So, I mean, nothing really fits distance-wise. The numbers are way, way, way too big. So let me just turn this off so you can see the work a little bit. There it is. Okay, so here's the work. And that's basically lesson 11. The whole thing is comparing the two kinds of tables. The work we did today was we practiced scaling up and scaling down using multiplication and addition for scaling up, and we did division and subtraction for scaling down. Then what we did is that we looked at two different items, or two different people, or two different things, whatever it is, two different events. And then we looked at, what's the ratio in there of two items as well, like time, 3 to 75, 5 to 125. And then we compared it with somebody else who has the same items but different values. Okay? I'm hoping this lesson worked out. I hope it made sense. This was 21 minutes, 30 seconds long. I'm trying to trim the videos down, but I'm just hoping it helps you understand when we do the homework and we discuss more of the concepts. Lesson 12, I'm going to put it up momentarily. So I'm going to keep putting videos up tonight until my battery is dead. So Lenovo makes a great machine, but I don't know, this lithium-ion battery. So if you have any other questions, please feel free to comment below. I'm going to probably start to do live tutoring on Thursdays. I'm going to make an announcement in a separate video in a few seconds here. All right. So any other questions, please let me know. All right. And have a good day.